Hi, I'm Andy, and this is my lesson on constructing objects in Java. In this lesson, I'll show you how to write a simple constructor for our rectangle class. I'll also discuss what a constructor does, how Java's default constructor works, and how instance and class variables are stored in memory. Let's get started. Let's continue working on the rectangle class from the previous lessons. As you can see, we have our instance variables, but we haven't made any constructors yet. Constructors are blocks of code that build objects. Since this is software we're talking about, we're not talking about building actual physical objects, we're talking about building virtual objects in the computer's memory. Here's what I mean. Let's put our first constructor in the rectangle class. Notice we used the keyword public in the constructor header because we want to allow outside code to create rectangle objects by executing this constructor. Also notice that the name of the constructor, right here, must exactly match the name of the class. That's how the Java compiler knows that this is a constructor. Now let's add code to the body of the constructor. The job of a constructor is to build objects in memory by initializing the instance variables to correct values. Let's have this constructor create a rectangle object whose length and width are equal to default size. We also need to initialize ID. Before we do that, let's increase the class variable numRectangles by 1, since the constructor is creating a brand new rectangle object. Remember that normally we access static variables and constants by putting the name of the class and then the dot operator out in front, like this. We can do that here, but since default size and numRectangles are defined in this class, right up here, we don't have to. Now we need to initialize our last instance variable, the one called ID. We'll just use numRectangles for the ID, like this. By the way, some Java programmers like to put this dot in front of these instance variables to emphasize that it's this rectangle's instance variables that are being initialized, not some others. I won't do so, but you certainly can if you think it makes your code easier to understand. And that's it for the constructor body. After this code executes, all 3 instance variables will be initialized to correct values. Let me show you how that works. Constructor code executes when you create a new object using new. Let's do that in our main method. This line of code does 3 things. First, new carves out space in memory for the rectangle object. Then that constructor code that we just wrote executes and initializes the 3 instance variables, like this. Lastly, the address of the object gets returned and stored in the rect reference variable. Remember, we use an arrow to show which object a reference variable refers to. So after this line of code executes, we should have a rectangle object that we can access through its reference variable called rect. Let's test that out. First, we need to temporarily make these instance variables public so we can access them from the main class. Now we can print out the values of all 3 instance variables in a couple of print line statements, like this. Now let's run our code and see what happens. So it looks like our rectangle object was created successfully. All 3 instance variables were initialized to correct values. Now let's see what happens if we remove the constructor by commenting it out. Now our rectangle class has no constructors. Let's see what happens when we try to construct a rectangle object and print the values of its instance variables. Somewhat surprisingly, the code worked and a rectangle object was created. And it looked like all our instance variables were initialized to a value of 0. Let's figure out how that happened. Well, first, you need to know that every class must have a constructor. So if you don't put a constructor in your class, the Java compiler makes one for you. This constructor is called the default constructor because it's the constructor that will be used if none are defined in the class. The default constructor didn't really do much here. It didn't even initialize our instance variables. That happened earlier when the variables got created. Java automatically initializes integer and double variables to 0 if you don't assign them a value. It's usually a good idea to use your own constructors rather than rely on the default constructor. So let's uncomment out the rectangles constructor. Let's also change the access modifiers for our instance variables back to private so that we properly encapsulate our object data. Before we go, let me show you the difference between how instance and class variables are stored in memory. Look at these two lines of code creating two rectangle objects, one referenced by R1 and the other by R2. Here's a nice visual representation of these objects and their references in memory. Notice that each object has its own copy of the instance variables. On the other hand, class variables and constants, also known as static variables and constants, are stored in one common area, like this. After these two lines of code execute, num rectangles has a value of 2, because the rectangles constructor increments this variable's value by 1 each time it executes. Again, the most important thing to notice in this picture is that each object has its own copy of instance variables, but there's only one copy of all the class variables and constants. And that wraps up this lesson on constructing objects in Java. I'm Andy. Thanks for watching and coding with me today.